Hi guys, I'm Marketa and I would love to explain to you today how PWM works. We will start with simplified version. Let's talk only about switching on and off for some specific time.
This switching can be drawn as a square wave where upper line shows on state and bottom one off state. Now I will explain some basic terms. Let's begin with a period, which is repeating part of the signal. For example, it is a pink part, but also it can be an orange one, because both of these parts are repeating in our signal. Our signal is changing between on and off state every 0.1 second. Then period, usually described by big letter T, is 0.2 second. Frequency is how much periods are repeated per second. Is described by small letter f. In our case, frequency is 5 Hz. In other words, our period will be repeated 5 times within 1 second. Duty cycle describes how much percent on state is within one period. We can calculate it by putting on time divided by period and make it equal to our unknown duty cycle divided by 100%. If we finish our calculation for this case, duty cycle is equal to 50%. We can have different duty cycles. For example, let's say that we have a 1 second period and 0.1 on state. That means we have a 10% duty cycle. Let's go a little bit deeper about how PWM works. If we look inside Arduino, we find out that there is an 8-bit counter. That means values from 0 to 255. We also have our input value, which is actually required duty cycle. This input value is written into PWM register and is between 0 to 255 in this case. For example, in Arduino we write this value by analog write method. Next important part is a comparator, which compares these two inputs and together with counter reset is behind PWM generation. Comparator basically set the output to 0 if the counter is smaller than our set value and 1 if the actual value of the counter is bigger. Let's draw it for better understanding. Firstly, we have 0 to 255 counter. At the moment when the count is equal to a maximum of the counter, the count goes back to 0. Firstly, our output is 0, since no duty cycle is set. But when we set, for example, 125, so almost 50% duty cycle, at the moment when the count is bigger than our set value, signal jumps on state, but when the counter is reset, the signal goes back to the off state. The set value is valid until it's changed, so if we go further, the same thing will repeat again and again. I wanted to compare basic changing on and off on Arduino pin without PWM versus using hardware PWM pin. For this case, I made a simple LED circuit with an oscilloscope. First LED with our software PWM is connected to pin 8 and the second one with hardware PWM is connected to pin 5. Of course, there is some advantage and disadvantage for both approaches. In case of using hardware PWM, we cannot change frequency. That is something that we can do in software PWM, but it is only easy if there is no other code in the main loop. If there is a code in the main loop, we have to be aware, know the exact time of every operation done there and count with it. For hardware PWM is used analog write to pin 5, which have approximately 980 Hz PWM. And for software PWM is used digital write method on pin 8 and LED is turned off and turned on with a frequency of 1 kHz. I will, for example, set a 20% duty cycle. Both graphs are very similar. Only in software version there is an issue with signal. It seems like the signal is not stable, but we can fix it by switching off the interrupts. Now it's possible to see that signals are same. We will check it one more time for 50% duty cycle.
Thanks for watching, and I hope that you learned something about PWM.